Welcome back to my channel. We're going to get started on some power rules. So today we're going to be learning about what those patterns were telling us. So before we get started, don't forget to like, subscribe, and hit that notification bell. So today we're going to be talking about power rule. So we have the limit definition of a derivative. We did a bunch of stuff to see if we could find a pattern. So on the one hand, when we had the derivative of a number by itself, we kept getting an answer of 0. So the derivative of any constant where it's just a number by itself is 0. On the other hand, we have this thing called power rule. And what power rule is telling us is that we take our exponent we currently have, multiply it by the coefficient in front, in this case it'd be 1, times n, and then we take 1 away from our exponent. So n times x to the n minus 1 is generally what we see when we talk about power rule. The other thing that we need to kind of keep in mind is that there are some rules that we take a little bit for granted, but we need to define them a little bit anyways. So we have the rule of constant multiples. So if k is a constant number, then our derivative would just be k times the derivative. So the derivative of k times f of x is the same thing as saying k times the derivative of x. If we have a sum, we can take those derivatives of our sum and separate it into the derivative of f, so f prime of x plus the derivative of g, g prime of x. Same thing goes for difference. We can take our sum and just take the derivative of f minus the derivative of g. So we can kind of ignore some of these things and not worry about it and just take individual pieces as derivatives. So we're going to find some derivatives using the power rule. So if I want to take the derivative of 7x to the fourth minus 10, I'm going to do f prime of x equals. We need f prime of x to say that it is a derivative. So one thing that we don't have to show, but I'm going to show for the first little bit so that way we can make sure we know what the pattern is to just write out what we're doing. So we have 7 to begin with, and the derivative of 7x to the fourth is using power rule. So we're going to take that 4 and multiply it out front. We have x, and then we are going to do 4 minus 1. This is the derivative of just 7x to the fourth. This minus 10 is a constant, so the derivative of that would be 0, so minus 0. So 7 times 4 is 28 x to the third power. So f prime of x is equal to 28x to the third power. Okay, we have 4x squared plus 6x cubed minus 3x plus 4. So we have y prime equals 4 times 2 is 8. X to the first instead of x squared, and we don't need to write x to the first. We have 3 times 6, which gives us 18, x squared. When we have something raised to the first power, we have 1 times negative 3, and then when we bring our exponent down 1, we would get x to the 0 power, but x to the 0 power is 1, so when we multiply it, it just kind of goes away. And then we have a plus 0, which we don't even need to write. So when I'm doing this, this would be all I have to give in order to find that derivative. Sometimes we reach problems like this, and this is not in the form that is power rule, so we need to change it. So we need to use those exponent rules to kind of change what we have. So our exponent rule for this is when we have something that looks like a root and a power, we can take that x and it turns into a fractional exponent where the power is on top and the root is on the bottom. So if we do that here, that'll be x to the 4 over 5. From here, we can now take the derivative because we have x to a power. So I have g prime of x is equal to 4/5 x, because 4/5 times 1. And then we're going to take away 1. But when we take away 1, we're really taking away that common denominator version of it. So instead of taking away 1, we're going to take away 5 over 5. So we get 4/5 x to the negative 1/5 power. Okay, so here is where, depending on our problem, is going to be a little bit different. This is an answer, so this is a fine place to stop if all we have to do is write it out. But if it's a multiple choice question, they may not give you an answer like that in that form. So we may need to do some work to kind of move it back. So if it's a multiple choice question, we can't necessarily leave it like this, but we might be able to. If it's not, we can leave it just like what it is here and then be done. So if we need to move it back, one thing that we need to know is we have a negative exponent. So I'm going to take that negative exponent and move it to the bottom of our fraction, because if I have x to the negative something, that's the same thing as saying 1 over x to that something. Okay, so I have 4/5, and then I'm going to change this to 1 over x to the 1/5. Okay, so we can kind of do two things here. I have two fractions that are realistically being multiplied together, so I can do the tops multiplied together to bottoms multiplied together. So I have 4 divided by 5 times x to the 1/5, and we can go ahead and change it back to our root. So I have 4 divided by 5x. My power is 1, and I don't need to write it, but my root is 5, so I'm going to have 4 divided by the 5th root of x. So if I needed it to be in a multiple choice answer, this is probably the form that they would give us. There is always a chance that they might give us something that looks like this, but it's not guaranteed. Okay. We have something like this where we need to kind of change what it looks like still. So the first thing I'm going to do is deal with this exponent. So I have 2x cubed, that's 2x times 2x times 2x, or I can think about it as 2 cubed times x cubed. So 2 cubed is 2 times 2 times 2, which happens to be 8. And we have an x cubed. Okay, well, we don't want the x in the denominator, so we need to move it out. When I move it out of the denominator, we are going to have a negative exponent. So I have 5/8 x to the negative 3rd power. So now what I'm going to do is I'm going to go ahead and change it, or take our derivative, so g prime of x equals. So we're going to multiply these together. So we have negative 3 times 5/8. So this would be like saying negative 3 over 1 times 5 over 8. X. And we have negative 3, and we are subtracting 1. So negative 3 times 5 is negative 15. 1 times 8 gives me 8. X. Negative 3 minus 1 gives me negative 4. So we have negative 15x, or negative 15 over 8x to the negative 4th. And then if I need to change it back, I can go ahead and move that x back to the denominator. So I have 15 over 8x to the 4th power. So we have another one here where we need to kind of change what it looks like before we can do anything with it. This one has a 1 over 2 times the cube root of t squared. So I'm going to just leave that as a 1/2, and then we're going to change it. So we have a root, and it's in the denominator, which means we have a negative and a fraction. So our power is 2, our root is 3. So this is what I'm taking the derivative of. So x prime of t equals 1/2 times negative 2/3. We have a negative 2 over 6. T, we are taking 1 away from 2/3, or negative 2/3, which is really just taking away 3 over 3. So this would be negative 5/3. Okay, if I were to simplify this, the first thing I'm going to simplify is this fraction. 2/6 is the same thing as 1/3. I can move t to the negative 5/3 into the denominator, and I can go ahead and change it back to that root. So 3 is in the denominator, so we have the third root of t to the 5th power. So we have what it would look like in our other version. Our last example here for power rule is, or no, not our last one, but our almost second to last one is we just need to sometimes multiply things out or divide things. So I need to multiply this out before I can take the derivative of it. So I have t times t, so I get t squared. I have a minus 2t from t times negative 2 and a plus 4t from 4 times t, giving us this minus 8 at the end. So I could take the derivative as is, but I know that we have a like term, so I'm going to go ahead and combine those like terms before I take my derivative. Those like terms I can either combine now or I can combine them after the derivative. So we have w prime of t equals t squared. If we use power rule, that 2 is being multiplied by 1, so we have 2t. 2t to the first power gives us 2, and that minus 8 just goes away. Okay, and then our last one here is we're going to divide out t squared from everything before we take the derivative. So I really have t to the 4th over t squared minus 12 t cubed over t squared plus 17 divided by t squared. Well, t to the 4th divided by t squared is t squared minus 12 t cubed divided by t squared. And then this last part, we don't really have anything that goes, or there's nothing that can divide out. So we're just going to go ahead and change it to that negative exponent. So we have 17t to the negative 2nd power. Now that I have it, I can go ahead and find its derivative. So t squared would turn into 2t. Minus 12t would turn into a minus 12. And then 2 times 17, but it's negative, so negative 34 t to the negative 3rd power. And if I wanted to change it, all I would do is change this last one to negative 34 over t cubed. So power rule is kind of like our bread and butter of everything with derivatives. It shows up all of the time. So we look at our derivatives with power rule and kind of like a different lens. So sometimes we need to simplify, sometimes we don't.